Hello and welcome to this section of our circuit analysis chapter. Here we're going to cover Thevenin equivalent circuits. So what is it? If I have a linear network consisting of resistors, independent and dependent sources, it can be transformed into a simplified circuit such that these two circuits are equivalent with respect to terminal behavior A and B, and the circuit will consist of an independent voltage source V Thevenin that is in series with a resistor R Thevenin. Our first section, independent sources. How do I find the Thevenin equivalent circuit? First step is to determine the Thevenin voltage, V Thevenin. So if I have an element between A and B, I am going to remove it in order to open the circuit between A and B. Thus, my current is going to be 0 and the load resistance is therefore maximum or infinite. And then I can calculate my voltage drop V Thevenin, which is also VAB, using my circuit analysis techniques. The second step is to determine the Thevenin resistance, or Thevenin. How do I do that? I need to find the short circuit current directed from A to B in my original circuit, and then I apply Ohm's law, which is R Thevenin is equal to V Thevenin over I short circuit, in order to find my R Thevenin. So here, the load resistance is going to be 0 at its minimum, and the current, my I short circuit, is going to be maximum. There is an alternate method to determine Thevenin resistance, or Thevenin, and it is by deactivating all independent sources. So if I have a voltage source, I short circuit it, and if I have a current source, I open the circuit in order to eliminate it. And then I find the equivalent resistance between A and B, which is also our Thevenin. As for dependent sources, the steps stay the same in order to find the Thevenin voltage and resistance. However, the alternate method to find R Thevenin is going to change. So we are going to deactivate independent sources, but also we're going to apply a test voltage or a test current across the terminals A and B, and we let them equal to a known value in order to solve for the other, and then while applying Ohm's law, we can find our Thevenin. As for applying Thevenin to the real world, one example is in battery charging circuits, especially those in smartphones and laptops. Thevenin's theorem is used to model both the charging source and the battery, and it simplifies the analysis of how the internal resistance of the battery and the charging source interact. This helps us calculate the charging efficiency, charging time, and voltage levels, which is especially useful when trying to optimize control circuits to extend battery life.
Now let's go through this example of finding the Thevenin equivalent of the following circuit. The first thing I notice is that these two resistors are in parallel and this resistor is short-circuited. So I can simplify the circuit to become the following. My first step is calculating the Thevenin. So the circuit is already open, so the current through the 1 kilo ohm resistor is equal to 0, so the voltage is also 0. I can eliminate it and therefore I can get this circuit. How do I find V Thevenin, which is also the voltage drop VAB? I can simply use voltage divider rule. So what is my voltage source? 40 into my resistance, which is 4K, over the equivalent resistor 4 plus 12K. Plugging that in will give me 10 volts. My second step is calculating R Thevenin. The first method is by calculating I short circuit. How do I do that? I can simply use node voltage at this node, and I'm going to call it C. Now, let's write my KCL equations. So it is VC minus 40 over my resistance, plus, since these two resistors are in parallel, I can just join them in one equation. So VC over 4 parallel to 1K is equal to 0. I have one resistor, one unknown, so VC is equal to 2.5 volts. Using Ohm's law, I can calculate my R short circuit, which is equal to VC over my R of 1 kilo ohms, which is 2.5 milliamps. Now I can finally get my R Thevenin also with Ohm's law, which is V Thevenin over I short circuit, which is equal to 4 kilo ohms. As for the second method for calculating R Thevenin, I need to deactivate the independent sources. I have a voltage source, so I short circuit it, and now I am left with this circuit. So I simply calculate RAB, which is the equivalent resistance across my resistors. These two resistors are in parallel, So 12K is parallel to 4K, and they are in series with my 1 kilo ohm resistor. Plugging that in will give me 4,000 ohms as well.